Hello everyone, this is Troy from H3C, and today I will introduce you the principles and configuration steps of MPLS L3VPN. It's a three-layer VPN technology which transmits VPN private network via BGP, encapsulates the IP messenger as MPLS label messenger at the edge root of the operator and forwards it on the backbone network. Compared with traditional three-layer VPN technologies such as GRE and IPsec, MPLS L3VPN has the following advantages. Flexible deployment. Traditional three-layer VPN needs to be established statically with poor scalability. However, MPLS messages can be forwarded on the public network through label tunnel, so VPN tunnel negotiation is not required. Better forwarding performance, as MPLS packets are forwarded more quickly than IP packets. Therefore, compared with other VPN technologies, MPLS L3VPN naturally has advantages in forwarding performance. Simple operation. Traditional VPNs can only be maintained and managed by users themselves, which is very difficult for them. However, MPLS L3 VPN networking can be completely built by the operator, and the edge device can also be maintained by the operator. Because MPLS L3 VPN has many excellent features and technology has been widely recognized and applied. Let's look at the principles and typical configurations of this technique in more detail. Okay, first let's learn the implementation process of MPLS L3 VPN. In MPLS network, messages with the same destination address or service level are considered as a class called FEC. Packets belonging to the same FEC are forwarded in the MPLS network according to the same path, which is similar to the packet forwarding in the IP network according to the destination IP. And the MPLS label means a label uniquely identify an FEC and just has local significance. In an MPLS network, devices capable of label distribution and label packet forwarding assign labels to each FEC, thus forming a label forwarding path LSP among devices along the way. For different private networks, MP-BGP will assign different labels on the device to achieve the isolation between different VPNs. So how is the packet forwarded in MPLS L3 VPN networks? Okay, now let's take an example of CE1 and CE2 in the same VPN instance to see the process of message forwarding. As shown in the figure, CE1 needs to access CE2. After the transmission of the private networks on both sides is completed according to MP-BGP, CE1 sends out IP messenger, and PE1 receives the messenger from the corresponding VPN interface. MP-BGP tags the inner layer label 28 to identify the VPN, looks for the MPLS forwarding table, and tags label 40 on the outside of the messenger, and then send it to the P device. When P receives this messenger, it can only see the out label 40. The P device tricks the penultimate hop hopping. Peel off the out label and send to the message to PE2. PE2 receives the message labeled 28 in the inner layer and finds the corresponding VPN. Remove labels and showing the IP header. Then send to the last hop, CE2. And at this time, the message was sent from IP network, passed through MPLS network in the middle, and finally sent to IP network at the other end. After learning the forwarding principles of MPLS L3VPN, let's take a look at the special configuration steps of MPLS L3VPN. The main steps include Step 1. Establish MPLS L3VPN LSP of backbone network. Step 2. Configure the VPN instance and the routine between P and CE. Step 3. Configure routine between P and PE. As shown in the figure, CE1 and CE2 belong to the same VPN1, and operators in the device are PE1 and PE2. And there is a large P device on the backbone network. For this network, we will go into the configuration details below. The first step is establish MPLS L3VPN LSP in backbone network. This step is the preparation, aiming at establishing public network LSP tunnel. We first realized the routing reachability between PE and P in the MPLS backbone network through the IGP protocol. We generally use OSPF or EASE protocol, and here we are taking OSPF as an example. After the interface address is configured, the device public interface address and loopback address are advertised into the OSPF process so as to achieve the reachability of the public interface and loopback addresses between PE and P device. The configurations of PE2 and P are similar to PE1, so omitted here. In the second step, we configure the VPN instance and the routine between PE and CE. Take PE1's configuration as an example. First, configure the VPN instance, including configuring the RD and RT. It should be noted that the export attributes of the local VPN instance VPN target needs to match the import attributes of the opposite VPN instance, as well as the opposite. Bind the interface to CE to the VPN instance. After the interface binds the VPN instance, the configuration, such as the address and the interface, will be cleared. So it is recommended to bind the VPN instance before configuring the IP address. Then the routing protocol between PE and CE is configured so that PE's VPN routing table can learn from CE's private network. We generally use OSPF or eBGP as the routing protocols, and take eBGP as an example here. Configure PE as its eBGP label on CE. Enable this label in IPv4 address cluster, and import direct routers, and advertise local routers to PE. Configure CE as eBGP label on PE. For PE, the label belongs to the VPN instance VPN1. So you need to enter the VPN instance via the BGP process before configuring it. After PE learns VPN routing information from CE, it stores it in the routing table of the corresponding VPN instance. PEs are D and export target attributes to these standard IPv4 routers and assigns MPLS labels to these routers to form the VPN IPv4 router. The configurations of PE2 and CE2 are similar to the PE1. The third step is to configure the MP-BGP labels and the routing exchange between PEs. Different from ordinary IPv4 BGP, MP-BGP labels exchange VPN v4 routing, which needs to enable MP-BGP labels and the VPN v4 address cluster of the BGP process. The configurations of PE2 are similar to PE1, just need to change the neighborhood address. After the configuration is completed, MP-BGP labels are established between PEs, and the local PE advertise VPN v4 routings include export target attributes and MPLS labels to the opposite PE through MP-BGP. The opposite PE matches the export target attributes of the VPN v4 routers with the import target attributes of the local VPN instance. If the import target attributes of the VPN instance on the opposite side PE has the same attributes value as the export target attributes of the router, the opposite PE will be added to the corresponding VPN routing table, and the corresponding LSP path will be named to guide the subsequent labeled message forwarding. And at this time, the routing table items of both sides are synchronized, and the VPNs and PE on both sides can be intercommitted according to the forwarding principle introduced above. At last, there are some points that require special attention. Let's emphasize again. Point 1. MPLS LSID must be the address of the 32-bit mask and reachable by routine. Point 2. VPN instances on PEs need to match each other's export and import attributes. Point 3. First bind the VPN instance to the internal network interface, and then configure the IP address. So far, we have finished the introduction of MPLS L3VPN. I believe you have had a relatively complete understanding of MPLS L3VPN through today's content. Thank you.